Welcome to this explainer. I am absolutely thrilled to get into this one with you today because we are about to completely shatter how you perceive the physical world around you. Think about it. Have you ever dropped something, maybe your keys, a pen, or your phone, and stopped to wonder why it actually falls? For centuries, we've just taken the answer completely for granted. But what if the very fundamental law holding us to the ground is, well, a massive illusion? Get ready because we're unraveling a cosmic mystery that is literally going to redefine the ground beneath your feet. So here's the big question. What if gravity isn't actually a pulling force at all? I know it sounds crazy, and it completely challenges everything Isaac Newton taught us. We've all been raised to believe that the Earth acts like this giant magnet, actively yanking objects downward. But if it's not some invisible rope pulling us toward the center of the Earth, then what on earth is actually happening when an apple falls from a tree? Let's start with Section 1, the problem with gravity and dismantling the spandex myth. To really get this, we have to look at the two fundamentally different ways humanity has tried to understand the universe. First up, we have Isaac Newton. He gave us the incredibly useful but ultimately incomplete idea that gravity is a pulling force between masses. And then Albert Einstein comes along and basically ruins our comfortable Newtonian worldview. Einstein proposed that gravity isn't a force at all, but rather the bending of the very fabric of space-time itself. But, what does that actually mean in plain English? Well, if you've ever taken a physics class or watched a science documentary, you've probably seen that famous spandex sheet demonstration. You know the one. A teacher stretches a piece of fabric, drops a heavy bowling ball in the middle to represent a planet, and then rolls a marble around it to simulate an orbit. It looks awesome visually, but it is deeply mathematically misleading and honestly logically flawed. Think about it. First, if this fabric represents all of 3D space, what is it bending into? What exactly is the space below the fabric? But the biggest flaw is the most obvious one. The only reason the heavy ball stretches the fabric downward is because of the actual gravity in the room. You literally cannot use gravity to explain why gravity works. It's just pure baloney. That brings us to Section 2, bending time, not space, and the 1D revelation. Let's strip away all the 3D complexity for a second. Imagine flat spacetime as just a really simple straight graph. The horizontal axis is space, and the vertical axis is time. In a completely empty universe with no massive objects around, these grid lines are perfectly straight. Now, if an object is completely stationary, it obviously doesn't move left or right through space, but it does continue moving forward through time, right? So on our graph, a stationary object just draws a straight line pointing vertically upward. It's moving through time, but not space. And this setup brilliantly illustrates our first massive realization, revolving around the number 1 billion. When you introduce a massive object, like the Earth, into our graph, it bends the grid. But here's the secret. It mostly bends the time axis, not the space axis. Near Earth, the geometry of time is distorted about 1 billion times more than the geometry of space. This means clocks closer to a massive object actually tick slower compared to clocks further away, while physical rulers barely shrink at all. So gravity's predominantly the warping of time. All right, moving to Section 3, why we fall down. Moving through bent time. Let's break down step by step how an object's innate momentum through time actually forces it to physically move through space. Step 1, our object is stationary, moving straight up its time axis. It has this innate momentum carrying it forward through time, and it refuses to deviate from that straight course. Step 2, we put it near the Earth, where the time coordinates are now drastically bent and skewed. Step 3, because the object stubbornly continues on its straight mathematical path through this newly curved grid, that straight line inevitably crosses over the space lines. Just by trying to move straight through bent time, it physically begins moving through space. There's no sudden momentum gained, no invisible pulling force. It's just the pure geometry of skewed time coordinates. But here is the absolute kicker. On our small, everyday human scale, we don't perceive the bending of time. Our brains are hardwired to see space-time as perfectly flat. So when an object follows its natural straight-line course through a deeply curved geometry of time, our flawed human perception tricks us. We see that geometric inevitability as a sudden, forceful acceleration towards the ground. We essentially invent the concept of a pulling force to explain a mathematical curve we simply can't see. Which leads us to Section 4, the accelerometer truth, why your phone doesn't lie. Now, you can actually test this counterintuitive truth right now because your smartphone's internal sensors will reveal exactly what's happening. If you pull up the raw accelerometer data on your phone while it is just sitting perfectly stationary on your desk, the data will tell you it is actively accelerating upward. But if you drop your phone off that desk, the exact moment it is in freefall, the acceleration drops to absolute zero. Yeah, you heard that right. Sitting still means you're accelerating, falling means zero acceleration. To make sense of this, we really have to redefine true acceleration. In physics, it's defined as any time an object does not move in a straight line through spacetime. Remember how objects naturally want to fall straight through bent time? Well, when your phone is sitting on a desk, or when you are standing on the floor, the physical matter of the Earth is physically blocking you from taking that natural path. The ground is literally dragging you, pushing you off your natural straight line course through spacetime right now. That upward push from the ground, which deviates your path, is true acceleration, and it is the exact reason you feel the physical weight of your body. As it turns out, there's a great quote for this. Accelerometers don't have incorrect intuition, they just spit the truth. Unlike our human brains, which are so deeply biased to assume we live in a flat, uncurved universe, machines don't care about our feelings. They happily bypass our human bias to measure the raw mathematical reality of the universe. When they're falling, they read zero, because they are finally moving freely along their natural path. That brings us perfectly to Section 5, the equivalence principle and the grand illusion. So if you were to map out the space-time path of a person accelerating in a rocket ship through completely empty, flat, deep space, and then compare it to the space-time path of a person standing completely still on the surface of the Earth, those paths are mathematically identical. There's absolutely no physical or mathematical way to distinguish between accelerating in deep space and feeling the pull of gravity on Earth. Why? Because they are the exact same thing. You are constantly accelerating right now just by standing still. Finally, Section 6. A universe of geometry, going beyond gravity. If gravity isn't a true force, but just the geometry of space-time bending, you have to wonder about the other forces of nature. Einstein wondered if all forces could just be the bending of specific coordinates. And it turns out, modern physics uses a framework called gauge theory to do just that. Instead of traditional pushes or pulls, it maps electromagnetism, the weak nuclear force, and the strong nuclear force to the intricate curvature of internal mathematical geometries known as U1, SU2, and SU3. Meaning the entire physical world, all the fundamental forces can be treated as shifting, bending geometry. To wrap up the main ideas here, consider this beautifully poetic thought from the source material. Reality itself seems to be a geometry. And whenever a particle exists, it doesn't just move through that geometry. It changes what geometry means. The universe isn't just some static, empty stage where particles bump into each other. It acts as this living, breathing, mathematical fabric that reshapes itself with every single bit of matter and energy it contains. So, I want to leave you with a final provocative thought to chew on. If the very gravity holding you to your chair right now is just an illusion of bent time, what other everyday forces are secretly just the mathematics of a reshaping universe? Take a second to look around the room you're in right now. Nothing is as flat, as simple, or as straightforward as it seems. Thank you so much for joining me for this explainer. Keep questioning your reality, and I'll catch you next time.